Hello Year 10 Triple. This lesson carries on from the pressure calculations that we had a look at. All of these handouts you are going to receive via the post. So this one, 19B, you will receive via the post. What we looked at last time was you've got an effort force going in of 30 newtons. And you get a larger load force coming out. Why does this occur? Well, liquids are virtually incompressible. So if you place an effort force on a closed system, and we've got this closed system here, the pressure remains the same throughout the system, but if you increase the area, then you increase the force. So what we get is a force multiplier. Let's move on to another question now. We have here a mechanical digger, and you can see you've got an input force, and you are going to get a larger output force. It's going to be bigger. Why is that? Well, the surface area here is smaller than this larger piston surface area here. So you're going to get another force multiplier. The pressure will stay the same because liquids are virtually incompressible, but the force will increase, as I'm going to show you now. So, question A. Why are liquids more effective than gases for use in this application? Because liquids are virtually incompressible. So, let's have a look at B. B, we're trying to calculate the pressure. So pressure is force divided by area, and that is 10,000 divided by 0.0004, and that gives us 25 million newtons per meter squared. Newtons per meter squared is the pressure. Now, what will the pressure be at piston B? It's going to be exactly the same. So question C, pressure acts the same in all directions in a liquid. And then D, write down the output force. Well, the force is pressure times area, 25 million multiplied by the area, 0.025, and that equals an output force of 62,500 newtons, which is much larger than the input force, which was only 10,000. This page here, I'd like you to write out. We've seen that the units of pressure are newtons per meter squared. There's another unit called the Pascal, or PA. 1 PA, 1 Pascal equals 1 newton per meter squared. Atmospheric pressure. Well, gas particles in our atmosphere reach up about 15 kilometers beyond the surface of the Earth. And these particles press down on us and exert atmospheric pressure. Atmospheric pressure is 1 times 10 to the 5 pascals, or another way of writing down 1 times 10 to the 5 is 100,000 newtons per meter squared. That is 1 atmosphere, or 1 bar. Now, gas pressure is created when gas particles hit the walls of the container that they are in. They generate a force over a certain area on the walls of the object. Gas pressure can be measured using a pressure gauge, like a Bourdon gauge. Now, we've got a tin can here. It contains lots of gas particles. They are all moving, bang, hitting the inside of the container, generating a pressure, and then striking each other and then smacking into the container again. So they are generating a force over a certain area. So they're generating a pressure. But of course, on the outside of the tin can, you've got other particles, air particles, crashing in, bouncing off, hitting each other and crashing in and hitting the can again. And normally those pressures are equalized, so the can is not crushed. Okay, the next couple of questions 1 to 4, you need to write down, include an equation, show your workings and provide an answer. I'm just going to put the answer down, but you need to go through the process, right? So for example, with the first one, I'll do the first one. Calculate the pressure on the ground when this person stands on their left foot. So pressure, P divided by P equals F divided by A. What's the force? The weight force is 700. They're just standing on their left foot, 196. 700 divided by 196. To 1 dp is 3.6 newtons per lookout centimetre squared. Notice that the left and the right foot are not equal. That often happens. Very rarely I've come across students that have got equal sized surface areas for their left and right foot. Have a go at B. I'll give you the answer in a second. 1.7 newtons per centimetre squared. The pressure's gone down because of course the surface area has gone up. You're adding both left and right surface area now. Student changes into high-heeled shoes. Calculate the new pressure. It's force divided by area. It's the same force, 700 divided by 40. Pressure's gone right up, 17.5 newtons per centimetre squared. And then B, explain what would happen to a wooden floor if the student balanced on the heel of one of the stilettos. Use these terms. The surface area would be dramatically reduced. Even though the force would remain the same, the pressure has increased, and so there is a large amount of damage to the floor. My mistake. 16,000 newtons. .5 times 10 to the 5. Okay, let's have a look at pressure now. Once again, you can just about make out that there's two divers near a shipwreck. When you go underwater, the pressure increases, and look what happens to your body. In particular, look at the size of the lungs. The further you go down, the more squeezed your lungs become. And look at this person's body here. It's under tremendous pressure. He's a free diver. What I would like you to write down is this little section here on Boyle's law. The pressure exerted by a gas is inversely proportional to the volume it takes up if the temperature stays the same. Now, what on earth does that mean? Well, let me just try and explain now. As long as the temperature stays the same, Boyle's law states that you've got a certain volume at the start. There it is. If you double the pressure, you half the volume. Hello, sorry about that. So I'm going to go through that again. Boyle's law. You've got a certain volume at the start, but if you double the pressure on it, you half its volume. So it's squeezed down, just like these lungs have been squeezed down, just like his body has been squeezed down. That is the first lesson finished with. Have a break.